Hello everyone and welcome to this course on how to use the TMS320 F28379D microcontroller from Texas Instruments for power electronics applications. This course is a beginner level course which is ideal for power electronics engineers to start using microcontrollers in their power electronics projects. So this course will focus only on those peripherals of the microcontroller that are absolutely necessary to get started with power electronics projects. In this course, I'll be using the low-cost Launch XL F28379D development kit, which is readily available from either Texas Instruments or from many other electronics vendors. Besides the kit, all other tools and documentation that we'll be using in this course are available for free. In a later lecture, I'll be also describing to you how you can set up a very low-cost home lab using some basic electronic components such as oscilloscopes and a few other basic components. So this chart describes where the microcontroller that we are going to use in this course is currently located. So in this particular chart, on the x-axis is the processor speed in millions of instructions per second, that is MIPS. And on the y-axis is the flash memory, which of course is very useful because this determines how much data the microcontroller can store, which is both your program data as well as data which is captured from various peripherals. Now, if we take a look, the microcontroller that we are using, which is the TMS320 F28379D, can be found in this particular location. And what that implies is that this is the second most modern microcontroller which is currently available. For example, if you take a look, the most advanced processor which Texas Instruments currently releases, especially for power electronics applications, can be found here, and that is the F29H85XT. And this is of course very powerful because it is more than 1200 million instructions per second, and it also has a very large flash memory, almost greater than 2 megabytes, which is a lot for a microcontroller. But our microcontroller is not too far, and this gives you an idea how powerful this microcontroller is. For example, if you are coming to this course from the F28069 course, you will know that the F28069 has a maximum frequency of 90 MHz, and that means it's way below on this x-axis. So this just shows you that the microcontroller that we are going to be using in this course is a very powerful microcontroller with some very advanced functionality. Now, as already stated before, this course will focus only on those features of the microcontroller which are necessary to get started with power electronics projects. Now, a microcontroller such as this, and most microcontrollers that have been released nowadays, are very vast in their peripherals. That is, they have a vast number of peripherals for various applications. Because nowadays, even many power electronics projects require a number of peripherals for various reasons. For example, even nowadays, in terms of power converters, you need to update the firmware remotely through Wi-Fi or through another form of internet connection. And that essentially means that the microcontroller on board the power converter has to be able to update its firmware through Wi-Fi. So these things are also necessary in complete products. But however, in this course, I'm going to only get started with the basic peripherals which are necessary for power electronics projects. Now, the reason for that is very simple. If you take a look at any of the courses on microcontrollers which you will find online, you will find that very few of these courses are targeted towards power electronics applications. Most microcontroller courses are dealing with communication or signal processing or various other electronics applications and not towards power engineering applications. And the idea of this course, and also many of the courses that I create, are to fill this particular gap. That is, to help power electronics engineers get started with their projects, and therefore the idea is to focus only on those basic peripherals such that they can get started by controlling power converters. But instead of actually trying to describe every peripheral there is in this microcontroller, I will be dealing with a limited number of peripherals. But those few that I deal with, I will go in great depth. which means that you will have not only the theoretical knowledge, but you will also have the practical knowledge on how you can program those particular peripherals. So this particular microcontroller, which is the F28379D, has two processors, and it also has two control law accelerators or CLAs. However, in this course, I will not be dealing with control law accelerators. I'll be dealing only with the processors. But however, I will be examining how you can program both processors in each and every example in this course. So therefore, not only will you learn how to actually control the processor and the peripherals, you will also learn how to share the peripherals between the two processors, and also finally how you can communicate between the two processors. So these are all the things that you will learn in this course. So in this course, I will be using C programming with the Code Composer Studio IDE program in order to program the microcontrollers. Now in recent times, you will find many graphical user interfaces and graphical tools in order to program your microcontroller. And many of these are becoming very popular, especially in R&D, where not only can you use these graphical tools, but also many simulation softwares such as Plex, PSIM, MATLAB Simulink. They all have tools by which you can convert your simulation code directly into microcontroller code and program your microcontroller. However, the reason why I'm going to be using C programming with Code Composer Studio is that if you were to go enter industry and you were to look for a firmware developer job or an embedded systems engineer job, then in that case, you would be expected to program microcontrollers using C programming and not just use graphical tools. So one of the best things about using Texas Instruments is that it comes with a vast collection of examples on various different applications. And in this course, I will be showing you how you can import those examples that have been provided by Texas Instruments. And in the case of these examples, I will show you how you can read the source code, how you can read the C files, what are the different types of files which are there in a particular project, and what is the significance of those files. So besides programming, I will also be describing the architecture of the microcontroller and the peripherals. So therefore, you will learn how the microcontroller works and also how the peripheral works. And most importantly, when we are using different peripherals, we will be configuring and controlling the peripherals using specific registers. We will not just be using certain functions or certain API libraries, but I will describe to you how you can actually set up and configure peripherals using the configuration registers. And this gives you an incredible amount of power when you are controlling microcontrollers. So when I'm actually building projects, I will be going back and forth between C programs and the technical documentation to describe to you how you can use the technical documentation to read register maps and also to understand how those register maps can be translated into C programs. So with this, I will conclude on this welcome lecture. The basic idea behind this lecture was to give you an idea of how this course is all about, what you can expect from this course, and also what this course is dealing with. In the next few lectures, I will be giving you a little more of a background about this course, the requirements of this course, how best to complete this course, and who should take this course. So with this, I welcome you again to this course. If you have any doubts or you have any other questions, please do post in the Q&A forum and I'll be happy to help you out. Otherwise, I will see you in the next lecture. Thank you so much for listening and goodbye for now.